Okay, why am I showing you a poorly white balanced wall? Well, it's YouTube, so anything goes, doesn't it? If you'll just wait about 10 seconds, we should see what I'm about to show you, unless you're one of those clever people who can read the title. What I want to show you today is a InFocus DLP projector, which is what you're looking at here, and that's pretty nice. I'm also going to take a look inside a LP600 3 LCD projector. And as you can see, the LP640, which is my current old main projector, is a very nice sort of... no, hold on, this is the LP600, of course. The 640 is a 3 LCD model. And yeah, it's got good contrast, good throw length, and so on. I quite like it. Using the power of minimal editing, I'm now going to show you the LP640 that we're going to take apart. Yeah, there it is, the LP640. It's a fairly large unit by modern standards. It's got a whole heap of VGA input-output, a custom proprietary DVI interface, but you can get an adapter for that. Network interface that I've never tried. Composite shit quality video and serial control. There's also IR receivers all along. There's one, and along the side, and one at the front as well. So it's quite well spec'd in that regard. All the buttons are on the top there. Standard stuff. I mean, it's kind of neat. It's got speakers on top. Focusing is just done by outer ring here is focus, and there's an inner ring which is zoom. This is designed for a very short throw, unlike the LP600, so you can't put it very far back in a room or you'll get a simply massive screen that's probably bigger than your wall. So let's take a look inside it. So trying out a new camera position. To remove the top lid, simply pull this thing off, and there's a flat flex cable in there. There's also a small cable here for the remote. So that's the top lid and LCD assembly off. You can also see the speakers, and that's all running along this flat flex cable here. This is made in China. It's a DisplayTech board, Rev C. There's a little daughter board here with the LCD controller. So that might be slightly interesting to remove. It's probably a standard pinout. Speakers, not very good. This is the main board. As you can see, or as you might not be able to see, it says right here, P97 Bifrost, 10 layers InFocus 2003, designed in Norway, which is quite rare. I don't think they do a lot of board design in general in Norway. To remove it, we'll need torque screwdrivers. All these InFocus devices use torque. There are a ton of fans. A nice little feature here is that all these connectors are essentially unique in where they're placed and pin out. So there's, let's see, a 3-pin connector here, but this is a 4-pin, and then there's another 3-pin. So it's very hard to make a mistake when reassembling it. Architecturally, the 3 LCD projector like this consists of 3 LCD units here. The light source is a xenon arc lamp, which is here, and there's a power supply for the device here, which lights it up. But the power connector's here. Then there's an optical path inside where it goes through several mirrors, polarizers, and filters, and then it's reflected out using prisms so that you get, for example, white, and then you split it up into red, green, and blue light. They're combined with a prism, and that's focused outwards. Let's see here, that's the controller for the power supply. There's also a secondary power supply, probably under here, I think, to supply the normal logic supplies. Let's see here. These flip up like this. You can just remove these, and the LCD with all three LCDs is one module with the lens that can be replaced. Right back, I'm going to get a screwdriver. Well, no luck finding my Torque 10 screwdriver, but I did find this bit kit, so that's good enough. Let's see, just unscrew all of these. If you're at all familiar with Volkswagen repair, then you'll probably have a set of Torque screwdrivers. This projector was thrown out due to a lamp failure. When I replaced the lamp, turns out there was a polarizer failure and also a rather strong burnt smell, which is why I'm not going to try to repair the polarizer failure. In addition to the polarizer filter being relatively expensive. I've already bought the lamp. I don't want to throw any more money into something that's probably going to catch fire someday. Let's see, we'll also need to get at some of these screws in here. And those are also Torque. They really like Torque screwdrivers, these InFocus people. The LP640 I had what's known as a light tunnel failure, which is basically a small mirror that focuses light internally. That's 4 little mirrors that are glued together at right angles in a way that essentially guarantees that it will not work after a few years under heat. So I replaced that and found that it worked. So, you know, at least there's that. Now there was a procedure for getting this thing out, but damned if I can remember it. I did this once. I think I may have to remove all these little things here. May have to come out. Yeah. Let's see here. Flathead screwdriver. I think I'll keep these actually. Never throw away a good screw. See, it's definitely looser now. There are no more screws. There you go. I always felt this was really poor design. So basically you have to bend these up if you want to get it out without getting a bunch of pins mushed together and scraping along the board here. Did I forget? No. Okay, there you go, the controller board. I'm not going to take a look at these circuits in too great detail. There's a Pixelworks Pixel device here near the input. I'm not sure what that logo is. Analog devices, isolation for the network, a custom chip here, possibly an FPGA. And let's see this Silink Spartan, that's also an FPGA. And some voltage supply, and this is possibly an EEPROM, Atmel 414. So who knows, I don't really care all that much. A few more analog devices on top here. You can buy these on eBay. I'm not sure why you'd want to, but they do sell them. Okay, now we have a better look at the actual workings of the internals here. You might not be able to see it, but there is actually a power supply here, which extends along the bottom bit here, which has got some little cardboard insulators and a fair bit of input filtering. It looks nice. There's more fans. The further in you get with this thing, the more fans you tend to discover. At this point it starts using Phillips screws for some reason. Possibly it's a modular design, or it was developed by a different unit. So let's see here. No, that doesn't fit at all. So we'll try this one. Yep, that's good. So if I remember correctly, we now have the option of disconnecting the lens LCD module by undoing these two screws. Oh, there you go. Oh dear, I just touched the LCD. Yeah, those are color-coded or LCDs. I'm not intending to run this anymore, but yeah, they are there, and there's a prism inside, and then just standard optics. Not really all that interesting, unless you're into that sort of thing. You can buy this as a whole module as well. Let's see, the fault in this unit is inside this thing, which is a complete module. That can be removed relatively easily. That's a torque screw, and all the ones next to it are Phillips, so not sure what was going on there. So we'll remove that. And you have to get at some various screws in here in order to undo it. Well, more torque screws, as you'd expect. Those two have to go. Let's see, it's getting looser. There's a couple more. There's one. And I believe we may have to loosen this thing before we can get it out. Okay, I've turned it upside down, and we're going to have to remove the lamp to go any further. Unlike on a DLP, this doesn't really have any adjustment. On the DLP you have the light tunnel adjustment, which if you set that wrong you get big black shadows appearing in the corner of your image. This is a lamp, which is fairly expensive. It's a xenon arc lamp. Yeah, metal chassis. It's very important if you own one of these to put it on a UPS, because if there's a power failure, your lamp will overheat, and especially if you have several right after each other, you will significantly shorten the lifespan of the bulb, and that's obviously undesirable. I keep mine on a 300 watt UPS, which is sufficient. Let's see, I believe I see the screw we have to get at to loosen the lamp housing. It's sort of all the way in there. I'll try to... Looks like it might be difficult to get at using this sort of screwdriver. Let's try it at an angle. No, that does not appear to be working. I think I know a trick. This works when you're using these cheap little screwdriver kits. There you go. Now this is loose. And let's see, it might be one more screw we have to remove. Yep. There we go. Since I removed that screw, I can just remove this as a module. This is the polarizer or filter assembly. Let's see if we can't get this thing out while we're in here. That's the screw I was getting at. It's one screw holding the assembly in place. And we'll try to get these high voltage connectors off. Doesn't look like they're very cooperative. Let's see. There's a ground lead here. At the bottom of the screen, it goes to the lamp. And then there's these two. I'm not sure. There might be some sort of sensor, because the two power leads are these two. And they go back to the power supply. And then this goes into here. That's okay. That might be that's a micro switch. When you remove the battery cover, this little tab here puts pressure on this micro switch to prevent you from running the device with the covers off. Obviously the lamp gets extremely hot, so that would be bad. I'm not sure what this is though. It might be some sort of sensor to determine if there's a lamp inserted, because it does a fair amount of testing of the lamp to determine if it's connected and current is monitored. Lamp current too low or too high triggers an error and then it shuts down. There's a lot of sort of health and safety junk inside these. Let's see, I can't... Okay, this goes back to the power supply. So I'm guessing these are sensors, and they're in series. So this is a sensor either for temperature or presence of a bulb. And that goes straight back to the power supply, which is sort of connected there. So that might be why it's isolated, if it's connected to mains and not part of the isolated power supply. Because the entire projector shuts down if you remove that lid while it's running. Obviously you can just wedge a screwdriver into the slot and it turns on right away, but that's kind of neat. I can't seem to remove these by hand. Fuck it. Yeah, there you go. I broke off something now, but whatever. Let's go back to the power supply. Here's a little fan to cool the underside of the I don't know, LCD polarizer assembly. Whatever this fan is supposed to cool. It's not doing its job very well, since this has quite a strong burnt smell when it's on. I don't deem it safe to run for any length of time, and thus also not worth spending money on to repair. So inside this thing, as you can see, I actually broke the plastic last time I opened it, and I was not being very rough either. It's just extremely brittle from the high temperatures. Let's see, just get these clips off. It's just a plastic cover and some filters for the LCD, to protect the LCD. That's a bit of plastic. You can see the filters are just sort of loose inside. You can just shake it around and pick them up. This part is adjustable, and I'm not sure what it does. But light input is here, and then there's these sort of bug's eye filters that Mike's Electric Stuff has a teardown video of a projector like this, which explains better than me what they do. They're kind of funky to look at, though. The broken part in this projector is definitely this. As you can see, it's all quite burnt. And it was worse. I opened up and slightly cleaned it just to see if that helped, but there was no change in the picture. There's a coating, it's fairly thick coating here, and it's just completely gone in the middle. So that's what's actually failed inside this. And then further along, there's just some little lenses. I might keep them. One side is flat. It changes a little. I'm not sure these are all the same. So lenses, and this is some sort of mirror. Let's see. There's the camera. There's my glasses. And if you look through it, you can sort of see that this is a very purple filter. Let's see, this like this. This is yellow. Looking at a white point source, it's yellow, and then also bluish. It seems to change depending on the angle. This is very deep blue. Looking at so it's reflective probably for one color, and then transmissive for another. This is very deep blue. Let's see what else we have. There's one more. Oh, hold on, there's a couple more. This is also a red filter. And see, this is a mirror, just a straight mirror. Nothing fancy about that. Another lens. Let's see, and this is also mirror. Let's see this bit. I don't feel like disassembling that. Okay, let's take a look at the Ballasts Driver, or whatever this thing's called, a high voltage power supply. It's held in with torque screws, as you'd expect. Wow, seriously, is it just one or two of these? It's amazing. Okay, there's one more there. This whole assembly is quite plasticky. Let's see. There we go. It's just held in with some clips here. There. Power input is from the main power supply. I assume it's a DC input, since it's colored. It goes through this RFI choke here. And let's see, we'll just... Got a bit of strain relief there. So let's try to get this thing apart. I have never dismantled this far in. Flathead screwdriver to the rescue. This is sort of a strange material to build something out of. It feels like almost like a carbon fiber material. It's probably just a special type of plastic. Possibly heat resistant. Let's see here. It's held in with the fucking awful clips. There we go. Well, big controller circuit here, just powered by this. Torque screws. So, input filter cap. Be sure not to touch this, it's probably still charged to a certain degree. Or maybe not. See some controller circuits underneath. Big sort of module here for control, presumably. Looks like these are optocoupled. Let's see, probably 2 switching transistors there. High voltage diode, possibly. Not sure what that is. Common mode choke on the output. Decoupling caps. Ground plane mesh construction. And, you know, fairly boring. There's a fair amount of high voltage creepage distance there. But, yeah. That's the high voltage driver. I'll put this in the rubbish bin and see if I can find a use for it at a later time. Okay, I just kept disassembling. I was able to get the power supply out as a module. Seems like it's attached to this metal frame, which provides some degree of shielding and, I guess, grounding. Got a fairly standard bit of gum inductors on the output. OK sticker. Looks like the output to the ballast high voltage supply is 300 volts straight, with an inductor ferrite choke on it, and that's probably controlled, possibly just current directly flowing through these wires that are the switches for the high voltage supply. So yeah, that's that. I think I'm going to keep this high voltage supply. It might be this and the high voltage supply. It might be useful later if I ever need a UV source, for example, for making my own circuit boards. The xenon lamp is a very powerful lamp and produces a lot of ultraviolet rays, which is normally filtered out before it reaches the viewer, but can be a problem. I also got a bunch of these little fans. Good fans are, as you might know, very expensive. So I got 2 of these. They're Sunyon maglev fans. There's, and 2 of these NMB. Not sure what quality they are, but they certainly weren't noisy. So the bearings were still good. 2 of those. The plastic in this is so brittle from heat that you basically just have to think about disassembling it, and it just sort of explodes all over the place. There's also bits of like custom duct work, like this thing, which is just a duct, and also this thing which sits under the lens barrel and has the 2 fans in here and lets you force air around it. So a bit of thought has been put into airflow in this thing. Let's see. Lens assembly. I'm not going to disassemble this. It's not going to be any. There's not going to be anything interesting in there. Let's see. This thing. I'm probably going to have to keep this. Let's see if I can disconnect the output cable. Yeah, just barely looks like I actually took the connector with me. How's that for quality? The pads weren't connected, just sort of came along with it when I pulled the connector off. Yeah, it's real quality stuff. So we'll keep that. See what else. I found these little IR receiver boards. They're relatively interesting. You can sometimes connect these up to Arduinos and things like that and have an IR receiver pretty quickly. So I found 2 of these. 3 if you count the one inside the chassis. Bunch of these little lenses and a bunch of torque head screws. This is all going to the skip, including this Norwegian designed controller board. Let's see here. Lenses, bits of lenses, bits of filters, mirrors, filter mirrors, mirror filters. I'm gonna keep those, put them in a bag, might find a use for them. Screws are not useful. There is a fair amount of screws in here. Yeah, so that was a sort of teardown of a projector. DLP projectors are very similar, but instead of the LCD, they have a single optical path up until the output, and then there's a color wheel, which is literally just a wheel, no sort of dust protection or anything. That's colored, has different segments, sort of spins around, and so when there's a red bit of segment on, that's I'm going to show the red portion, and then it shows blue, and so it's basically a black and white device, but it changes colors fast enough that you don't really see the flickering most of the time.